Hi folks, this is week 14. We're going to be dealing with electricity and electrical charge. One of our discussion questions is going to deal with renewable sources of energy and solar. And often one of the things that's missed in solar is that there is no single solution. Even our current power grid has a mix of, say, nuclear for base load or coal. In other areas, they'll use coal for base load. And then they'll use natural gas for what are called peaking plants. Okay, and that's when people get home and everybody turns on their oven and turns on their TV at the same time, and the air conditionings get turned back on, and that's when the electrical demand rises. Now, some of the base load plants can increase their load a little bit like that, but they want to run in steady state. What we use in the peaking plants is something that can start up really easily. Basically, it's the same technology as a jet engine. You push a button and you start her up, and you run the generators and you run them until they're no longer needed, and then you idle them and shut them down until tomorrow. Okay. Even our regular power grid has a mix of supplies. So the question is, how are we going to take and mix together things like wind and solar and geothermal and all of the other renewable sources that we have? And one of the suggested solutions is a high voltage DC backbone for the country. Basically, if area A, the wind dies away, and you're no longer, all you got windmills are sitting idle, or they're not producing power at quite the rate that you might hope for. Well, the wind is somewhere. Okay, so there's a big place. The wind is not going away. Okay, and so maybe some other place is producing power. And to be able to transmit that with as few losses as possible, there's some thought that we might be able to use direct current. Now, currently, our transmission grids use high voltage DC because we can use something like transformers to step up voltage and step down voltage very easily. We did not, in the early days of designing the power grid, use high voltage DC because the equipment, we didn't have the technology or the equipment to be able to easily step things up or down. But one of the things that we would do with DC is we would not lose, we wouldn't have the same transmission losses. There are transmission losses. You have charges moving back and forth, currents moving back and forth. You are creating radio waves. You are radiating energy. And you can take a fluorescent bulb under a transmission, set of transmission lines, and you can pick some of that up and they'll glow. Also, high voltage DC only needs one strand. Three-phase power requires 3 bands. So you could effectively double or triple your transmission rate with the same copper conductor if you were to transfer it over. Okay, all of the applications though for high voltage DC are for distances way in excess of anything that we would try to transmit with high voltage AC. And many of you work in the power industry, and you're invited to comment on that. And I do invite them because I did not work in the power industry. I was a nuclear power plant operator in the Navy, but I never worked in the civilian power industry. Well, in any case, I've included 2 videos below. Those should help cover some of the ideas behind high voltage DC, and I hope you enjoy them.